Hello everyone. Today, on behalf of TopGear, I'm excited to present to you our automatic stamping mechanism, a solution designed to improve the efficiency of repetitive stamping tasks. Whether it's for printing, marking or labeling, this mechanism automates the stamping process, saving both time and effort. Our objective with this project is to design a machine that can create a repetitive and consistent stamp pattern with minimal manual intervention. The idea is to reduce the physical effort required for tasks like stamping or marking, especially in environments where precision and speed are essential. The core functionality of our design is based on motor-driven gear system. This system transfers motion to both vertical and horizontal linkage, which work together to move the stamping head up and down. As the stamp moves in this consistent motion, it presses the stamp pattern onto a surface with precision, ensuring consistent result every time. The purpose of this mechanism is to increase efficiency by automating the stamping process. By eliminating the need for manual stamping, we are offering a solution that particularly useful for industry that rely on repetitive marking tasks. Whether it's stamping on paper, plastic, or other material, our design ensures that the process is faster, more reliable, and consistent.
For the design, we are using the ANSYS software, which is using the platform ANSYS SpaceClaim to design our mechanism. Our group designed an automatic stamping machine that equipped with the gear that has 1:2 ratio, in which a motor are connected to a small gear. For the simulation video, the simulation of the machine movement was made using the linkage software to aid in understanding of the mechanism.
So now let's dive deeper into the analysis of the stamp machine. So the analysis involves of position, velocity, acceleration and forces. So now let's move on to the position analysis for this mechanism. So from the graph, we can say that from 0 degree to 90 degree, the phase represent the return stroke for the stamp. So the displacement reduces significantly as the stamp moves back to the starting position. And from 90 degree to 270 degree, we see the active stroke where the displacement increase as the stamp moves forward, delivering energy. And lastly, from 270 degree to 360 degree, this is the retraction phase, and the displacements decrease as the stamp returns to its starting position.
I am Muhammad Shafiq bin Sohimi, and I am going to talk about the velocity analysis of our mechanism. So there are three velocity components that are acting on our mechanism, which is velocity at point B, VB, velocity at point C from link BC, VCB, and finally, the velocity at point C from link CD, which is VC. So first we establish the angular velocity of the gear, omega 1, to be 2.09 rad per second. From there, we can calculate the VB using the formula omega 1 times RAB. Then we sketch the velocity diagram according to scale and then measure the length using the ruler to get the VCB and also the VC. And finally, we can get omega CB and omega CD from the VCB and also VC. As for the acceleration analysis, the acceleration components involved has increased a bit compared to their velocity. So first, we have the normal acceleration at point B, ABN, and then the normal and tangential acceleration of C, ACN, and ACT. Then we also have normal and tangential acceleration of C in respect to B, ACBN, and ACBT. We can get the normal acceleration of B, CB, and also C from the angular velocities that we have calculated from our velocity analysis earlier. After that, we sketch the acceleration diagram and then measure by using the ruler to obtain the magnitude of the tangential acceleration ACT and also ACBT. When we get the magnitude of ACT and ACBT, we can calculate the angular acceleration of link BC and CD using the formula tangential acceleration divided by the length of their respective links. Finally, we could calculate the acceleration of point of interest x. For a force analysis, we have to find out the forces that are acting on each link in our mechanism. We have assigned the mass of the stamper to be 2 kg. The forces acting on link 2 is torque 21, T21, F21X, and F21Y, and also F23. On link 3, there are two forces, which is F32 and F34. On link 4, also two forces, F43 and F45. The forces acting on the links are equal in magnitude, but act in opposite direction.
So now I will be share with you 4 available design of the stamp machine in the market. So first we have manual stamp, which operated by hand and also a lightweight and portable machine. Second, we have pneumatic and hydraulic machine, which powered by compressed air and hydraulic pressure. And third, we have semi-automatic stamp machine, which combine manual input and powered by automated mechanism. And lastly, we have rotary stamping machine, which utilize the rotary stamping mechanism and also use with conveyor belt to ensure seamless material flow.
For the selection process, our automated stamping machine focus on 4 criteria, which is accurate stamping, upgradation and versatility, motorized automatic operation, and human safety. So our machine, our design is able to enhance the speed, accuracy, and safety of the machine, and it also use motorized operation, which increase the productivity rate and eliminates the direct human contact. So in conclusion, our automatic stamping machine effectively able to automate the repetitive stamping while ensuring that there are consistent and accurate results. So we also believe that our design have a potential for practical uses in various industries. That's all from our group. Thank you.